This video is going to cover the law of sines. So the law of sines is a way to find missing sides and angles in any type of triangle, not just a right triangle. So the law of sines is the sine of A over A, equals the sine of B over B, equals sine over C over C. So let's just notice something about this formula here. The capital letters A, B, and C that we're taking the sine of, those are referring to the angles of the triangle. And the lowercase letters are referring to the sides that are opposite those angles. So let's look at that in picture form. So here's angle A over here. Notice the side across from it, we're labeling lowercase a. Angle B, the side across from it is lowercase b. And angle C, the side across from it is lowercase c. When we're doing the problem, though, you don't need to stress so much over that. The A, B, and C, you want to think about just the angles and sides that are opposite one another. So here, let me show you what I mean by that. All right, for number one, we're going to solve for side A to the nearest tenth. So we're going to pick two sides and angles that we know are opposite one another, and that can include the variable. So what I mean by that is we know angle A and we know side A. And so we could write sine of 32 is over A. And we also know angle B is 104 and side B, lowercase b, is 18. So sine of 104 over 18. And then we're going to cross multiply and solve here. Okay, so when I do this, I'm going to get 18 sine 32 equals A sine 104. Divide both sides by sine 104. And when we're doing this in our calculator, just double check you are in degree mode. Hit your mode button, make sure degree is highlighted. And now I'm just going to type this into my calculator. So I have 18 sine 32 divided by sine 104. And we're looking for the length of A to the nearest tenth, and we get A is 9.8. All right, number two. We're looking for the measure of angle B to the nearest degree. So angle B is opposite this side of 25, so we know we're going to use that pair. And then we're going to also use this pair here with the 49 degrees and 21. All right, so the sine of B over 25 is equal to the sine of 49 over 21. Now, if we're thinking about this in terms of the formula that was given prior in the video, it's kind of like we're using this part of the formula. We're using B and C here and substituting in. So if it helps you to write that formula, you certainly can. But I'm really looking at the picture and saying, okay, I just want to focus on the fact that I need to use sides and angles that are opposite one another. All right, once we have that, we are going to cross multiply. So I have 25 sine 49 equals 21 sine B. I'm going to divide both sides by 21. And notice what we have here. So we have sine of B is equal to 25 sine 49 over 21. But remember, we want to find the measure of angle B, not the sine of B. So what I'm going to have to do is I'm going to say in order to get B, we have to do inverse sine. Right? Anytime you're looking for an angle, you're going to use inverse. 25 sine 49 over 21. So this could be a little cumbersome to type into the calculator, so think about it as you're going through. First, we need inverse sine, so I'm going to hit the second button, then the sine. And now I'm going to type in what's in parentheses there. I'm going to choose to stack my fraction here just so that it matches a little bit neater what I have written on my iPad screen. And we're going to hit enter. So we're looking for the measure of angle B to the nearest degree, and you can see that I got 64 degrees. All right, number three, we're solving for x to the nearest tenth. Notice in this picture there are no A's and B's and C's, but again, we don't need it. We want to just focus on sets of sides and angles that are opposite one another that we could work with. So I could use that the sine of x over 8, that's one set of opposites, is equal to the sine of 62 over 9. All right, and then we can cross multiply. So we have 9 sine x is equal to 8 sine 62. Divide by 9. And we're going to have a similar situation from the last problem where we're going to have to use inverse sine since we're looking for an angle measure. So inverse sine, and then I'm going to type in 8 sine 62 divided by 9. And to the nearest tenth, we get that x is 51.7 degrees. Number 4. Similar to the last example where we don't have A, B, and C, but we can still figure out our measurements that we're going to plug into the formula because we're just looking for the opposite angles and sides. So x and 84 degrees are opposite one another. 35 degrees and 7.2 are opposite one another. So the sine of 84 over x, remember whatever comes after sine is the angle, the degree measurement, that's why the 84 goes there, is equal to the sine of 35 over 7.2. All right, let's cross multiply here. And when you're writing your proportion, by the way, it doesn't matter. Like I did sine of 84 over x as the first fraction. If you had that as your second fraction, that does not make a difference. Also, when you cross multiply, it doesn't matter which diagonal you choose to multiply first. All right, so we're going to isolate our variable here. And in this case, we're looking for a side, so we do not need to use the inverse. So I'm just going to type this fraction right into my calculator. 7.2 sine of 84 over the sine of 35. And we're looking to the nearest whole number, so we get that x is 12. All right, for number 5, it says find x, y, and z, and round to each to the nearest whole number if necessary. All right, I'm actually going to go out of order here and not find x first because when I look at this picture, I can see very quickly that I can find y because I'm looking for the missing angle in a triangle, and we know the angles in a triangle add up to 180 degrees. So right away, I know that y is equal to 58 degrees. All right. Then let's look at our opposites here. So 82 and x are opposite one another. 11 and 40 are opposite one another. I don't want to use the 58 and the z with the x and 82 because I don't want to use a proportion that has two variables. So I have to pick that 40 degree and 11. All right, so setting this up, the sine of 82 over x is equal to the sine of 40 over 11. We're going to cross multiply and divide. All right, typing this into our calculator. So 11 sine 82 over the sine of 40. And to the nearest whole number, I get that x is 17. All right, now I need to find the measure of z. So I know that the sine of 58 over z, and I can use the 82 and x since we found x, but I'm going to choose to use the 11 and the 40 here. So sine of 40 over 11, and I'm going to cross multiply now. All right, typing this into our calculator, I have 11 sine 58 divided by the sine of 40. And again, we're rounding to the nearest whole number, so in this case, z is equal to 15. So my answers, y was 58, x is 17, and z is 15. All right, one last problem here. This is a problem that does have right triangles in it, but it also has a non-right triangle. So just keep in mind, law of sines does not require it to be a right triangle like SOHCAHTOA does, for instance. So it asks us to solve for x and y, and we're going to round to the nearest whole number. All right, when I look at this, one thing that I notice right away is that I could find this angle next to the 52. So these two angles are supplementary to one another, so I know that this is 128. And I also can figure out that angle at the top by subtracting these values from 180, and I know that this is 16 degrees. So what I'm actually going to do here is I'm going to redraw this triangle. I'm just going to slide it over. And I'm just going to separate it for a second from the rest of the picture so that you could see it a little bit clearer. And you could see on this problem now that I have a set of opposites, the 16 and the 15, it's a very narrow triangle here, and also the 36 and the x. So I can now find the value of x using the law of sines. So the sine of 36 over x is equal to the sine of 16. Remember, that's our angle. I'll erase here so you can see a little neater. Sine of 16 over 15. And we're going to cross multiply. All right, typing this into our calculator, raster around to the nearest whole number, and I get that x is 32. So what I'm going to do is I'm going to go back to the original picture. Where that x was, I'm going to put a 32 there. Now we have to solve for y. So I just want to point something out when we're solving for y here. Y is part of this triangle. It's also part of the big triangle. You could look at either. But whichever one you choose to look at, it's a right triangle. So this means to find y, you're actually getting the choice. If you want to use SOHCAHTOA, you could, right triangle trigonometry basically, or if you want to use law of sines, you could. Either one will work. For the sake of this video being about law of sines, I'm going to use the law of sines example, but you don't have to. If you wanted to do it with SOHCAHTOA, that's fine. All right, so we basically have a right triangle. We know this is y, this is 32, this is 52, and we also have that right angle in there, meaning we have a degree measurement of 90. So 90 and the 32 are opposite one another, as are the y and 52, and I can set up law of sines here. So the sine of 52 over y is equal to the sine of 90 over 32. All right, we're going to cross multiply and divide in this case. And then I'm going to go to my calculator. Let's type this in. We have 32 sine of 52 over the sine of 90. And remember, we're rounding to the nearest whole number in this problem, so y comes out to be 25. So x was 32. Y was 25. And again, just a reminder for that last piece, if you wanted to use SOHCAHTOA, you certainly could, and you would get the same answer. Thanks for watching, everybody. You can check out other videos on this playlist to learn more about trigonometry.